This is Miss Sebastian, and we're going to look at functions and solving systems of equations. What is the unit rate for each type of apple? So you buy 8 pounds of organic apples for $8.80. Then the graph shows the price for regular apples. So the first thing we see is that you can buy 8 pounds of organic apples for $8.80. So we're going to find the price per apple. So when you say per apple, that means divide. So $8.80 divided by 8 makes it $1.10 per apple. And that will be our unit rate. Now we're also going to look down here at our graph. For regular apples, I'll look at the price. That's going to be this part. And I see a 2. So it'll be $2 for one apple. $2 for one apple. So $2 an apple for those regular apples and $1.10 per apple for organic. So they must have been on sale. The price for pears is y equals 2.5 times x. Which line would have the steepest slope if the organic apples and pears were added to the graph? So we know that the organic apples on the last page were $1.10 each. And then we now have the pears. So $1.10 each. That would be here, here, 220, 330, 440, 550. So there's the organic apples. And then let's do pears in green. Okay, pears have 250 times x. So 250 times 1 would be 250. 250 times 2 would be $5. 250 times 3 would be $7.50. And 250 times 4 would be $10. Okay, so those are not the best drawn lines, but you can see that this green line up here has the steepest slope. That means if you're sitting on it trying to slide down, you would slide far faster on the green one than you would on the purple. So the steepest slope would be that 250. That also means, what is the rule for the function shown in this table? So I'm going to look and I'm going to see, okay, the change in x's, it's adding 1, adding 1, adding 1. The y's are subtracting 3, subtracting 3, and subtracting 3. So I know that my slope, or my change, y over x, is negative 3 over 1. And then we have our y-intercept here that is minus 6. So you could write it y equals the slope, negative 3x, and then our y-intercept. You could also see it written as f of x equals negative 3x minus 6. What is the function rule for the following situation? Rex paid $15 for a membership to the pool and pays $4 each time he goes to play golf. Okay, most of the time when you see function rule, you see f of x. You may also see y. They're the exact same thing. They're interchangeable. Okay, we know that each time he goes to play golf, so every single time he goes, and we're going to make the number of times he plays golf x. Okay, number of golf. Every time he's paying $4. Anytime you see the word each, usually that's going to be your slope. That's going to be right here, that 4.00, or maybe just 4. And then he pays one time for a membership. So that's going to just be plus 15. The reason I wrote both f of x equals this and y equals this is because I wanted you to know that you may see it either way. Find the solution to the systems of equations by using either graphing or substitution. So y equals 4 minus x. So the first thing I'm going to do is I'm going to graph these. I'm going to look at the first one, and I see this 4 is positive. That's going to be my y-intercept. And my slope is -1. So that means I'm going to go down 1 to the right 1, down 1 to the right 1, and so on. Okay, and I'm going to try to draw this line, so please forgive me. Okay, hopefully that will cover it. Okay, and then I'm going to look at my second graph, and I have a y-intercept of -3, and I have a slope of +1 there. So I'm going to graph that, and I see that my my intercept looks like it's at about 3.5, but we can't be sure. They hit in the middle of that, but we can't be sure exactly where they're at unless we do substitution. So I'm going to write my two problems over here. And I'm going to take my first equation, this 4 minus x, and it says y equals that. So I'm going to plug it in right here where I see y, because it says y equals that, so I can plug it in for y because I'm substituting. Just like when you substitute a player in to a sports game. So if I substitute a player, I'm taking one out and putting the other in. Now I'm going to solve for x. So I'm going to add x. I'm going to get it over to the right-hand side. So I've got 2x minus 3. Now I'm going to add 3, 2x equals 7, and then divide both sides by 2. Oh, x equals 3.5, because 7 divided by 2 is 3.5. So now all I have to do to find y is to plug it into one of my equations. I'm going to use the second one, x minus 3. The reason I chose this one is because I think it's easier. To subtract 3.5 minus 3 and get 0.5. So on our graph, we were correct. Find the solution to the systems of equations by using either graphing or substitution. So we're going to do both. So 2x minus 4, that means our y-intercept is at -4. Our slope is 2. Just going to go all the way up here, plotting my points because I know that my line is not the straightest it could be. go. And then I'm going to swap over to my second line, and I've got 3 as my y-intercept. And my slope is -2, which means I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And draw. Well, it's not perfect here, but it looks like it's right there. So I'm going to do substitution again to find my accurate point. So I see this part, y equals that, so I'm going to plug it into my first equation. -2x plus 3 equals 2x minus 4. So I'm going to solve. I'm going to add 2x to both sides because I want to get rid of it on the left-hand side. So I'm left with 3. Now I want to get rid of this minus 4. So I have to do the inverse operation, which is add 4. Over here, it forms that 0 pair and goes away. And I get 7. Then I divide by 4 on both sides to isolate that x to get it by itself. And I do get 7/4. And you can leave it like that. Now all we have to do, I'm going to put that in our equation up there. I'm going to plug it into one of my equations. So I'm going to plug it into my first one. So 2 times 7 is 14 divided by 4 would be 3.5 minus 4 would be a half, and that is negative. So -1/2. And yes, that looks about where our graph shows it. Find the solution to a system of equations by either graphing or substitution. So our first equation is y equals 2x. When we have y equals 2x, that means that our y-intercept is 0 because there's nothing added or subtracted there. And our slope is +2, which means +2 over 1. So every time it goes up 2, it goes to the right 1. I missed the dot right there. Sorry about that. There we go. So we can draw our line. Okay, and then our other line is y minus x equals 3. Well, I'm going to get that x on the other side so that it will be x plus 3 because I want it in my slope-intercept form. So that means my y-intercept is 3, and the slope is the coefficient beside x, which is 1. So I'm going to go up to the right 1, up to the right 1, up to the right 1. So it shows me my intercept is here. So that's my solution. So I'm going to look at my x value, it's 3, and my y value, it's 6. So I think 3, 6 is my solution. But now I'm going to try to solve by substitution. So I've got y minus x equals 3, and I have y equals 2x. I'm going to plug in this 2x where I see the y in this other equation, so right here. So I'm going to plug in 2x, and then I'm going to write the rest of the equation. Minus x equals 3. So 2x minus 1x just leaves me x equals 3. I'm done. I don't have anything else I need to do there. But now I can solve for my y by putting that 3 that we just found into the x spot there. So 2 times 3 is 6. So our solution we found by graphing is correct, 3, 6. So you could have done that by either method there. What will the graphs look like for a system of equations that has infinitely many solutions? So let's go through these. The first graph here crosses in one spot. That means we can tell that ordered pair, and this would be one solution because it only crosses one time. On the far right, where you see the blue and the pink line, and they are parallel, those are never going to cross. So those have no solutions. The middle is one line sitting right on top of the other so that those are the exact same line. That is what infinitely many solutions will look like. So infinitely many is going to look like this, where it is two lines, one on top of the other.